Into Elastic, I love it.
Oh, fabulous. Yeah, you're half committed to me. It's like I may or may not know enough about it. That's fair. That's very fair. All right. Do you need to do anything for recording?
No, I'm all set.
All right. Fantastic. All right. So look, my name is Mike. I work at Symantec. I also teach at UAlbany in the School of Business, teaching different computer science classes to business school majors, which is really fun. And thank you guys for your time, okay? And so, data is data, and that's going to be a theme here. Just please remember that data is data, but security data is the best. All right. So this is what we're going to cover today. Security analytics in general. We're going to talk about Elastic briefly, just so that I understand the general audience here. Quick show of hands. How many folks are familiar with Elastic? Like you've done at least one project? Okay. How many folks are wizards at Elastic? Yeah, I'm not. I was just keeping my hand up to demonstrate what to do. Okay, good to know. All right. So I'm also going to talk about the architecture components in order to make the solutions work. Right? At a high level, there has to be some network configuration. Stuff's got to talk. Log to timeline is a Python application that we use to create timeline, super timeline events out of certain systems. I'm going to talk about how I use that sometimes. I'm going to talk about Logstash, then Elasticsearch, and then Kibana. Then I'm going to give you some examples. The first example is going to deal with Shakespeare. If you're familiar with Kibana, you might know that their very first tutorial is, hey, grab this Shakespeare JSON and then do a couple things with it. So we're going to use that. And then break into some security-specific examples, Linux host data, some web logs, and then some malware research data that I have access to, and just show some kinds of things that you can do with it with Elastic. None of this is magic. None of this in and of itself is necessarily whiz-bang. The point is to just sort of show you some of the cool things we can do with the technology, and hopefully to maybe kickstart or inspire some ideas for you to use the technology to do cool stuff with your data. Because again, to come back to the general point, data analysis is data analysis, right? So your set of fields might be different from your set of fields, definitely different from your set of fields, but the general process we use to take the data, normalize the data, analyze the data, and present the data in a way that the pointy-haired boss understands what's going on is going to, generally speaking, be the same, okay? So just a quick note. He turned up the microphone, which is weird. So just a quick note. The talk description that is in the book said that I was going to look at the XPack machine learning recipes. In the time between I started building this talk and today, the Elastic licensing model has changed, and the XPack stuff is no longer free. That hurts me in many ways, and I'm just not going to give you a presentation that you couldn't then reproduce for free. So I changed. Basically, I built a new presentation for you, okay? So we're going to start out with an interactive discussion, then we're going to talk about configuring it, we're going to talk about, usually, when people think about Elastic, they think about logging, monitoring, and alerting in this near real time, okay? My current role, I do a lot of incident response. So I had this real interesting problem I had to solve. I have historical data, but I still want to use all these cool tools. How do I do that? We're going to talk about that, we're going to talk about how we ingest the data and how we ultimately create analytic capability. There will not be any terminators in this presentation. All right, so if you were like really focused on the machine learning part, I apologize, but I pulled it out because it's not free, right? And so then I said, okay, let's not talk about stuff that's not free. All right? We lost it. No problem. Wasn't committed. All right. So, thank you, XKCD. Just want to point out, this is not a talk about statistics, right? We're concerned about answering specific instances of security questions, right? I don't care about, like, is it or is it not mathematically valid. What I care is, can I find out the information that helps people make good decisions to keep their system secure, their data protected, that sort of thing, right? It's the difference between the theory of whatever and someone who is a first responder who actually keeps people alive, right? So we're more of the latter. We're trying a little bit down and dirty, just find the data we need to go do the things we need to do to keep the systems up, to keep the data protected. Any mathematicians in the room, what you do is important too, but that's not what I'm getting at. This is not a presentation about statistics per se. The more mature your security analysis capability becomes, the more you might need to build more scientific answers, right? But when you start, you're just trying to answer the question like, what the hell is going on? Who might be doing it? What does it mean? That's what we're trying to do right now. As you iterate, maybe you get more scientific as you go, right? Lastly, try to remember as you're using any technology like this to soften your language, especially when going up the management chain, right? It's always possible that our data model is a little bit incorrect, or that we don't have all the data we thought we had, and that somehow we end up with an incorrect answer. So just remember that. Also, it is very, very hard to prove a negative. So try to remember that as well when you're trying to use these data systems. Don't fall into the trap of thinking that you can prove every single thing that you wish you could, because sometimes you just can't. And hopefully that makes sense. So from my perspective, security analytics is just a constantly iterative process. You're asking questions, answering questions, trying to understand, and then wash, rinse, repeat, right? So hopefully that's pretty straightforward. Just as a general recommendation, we always try to start small. Ask an easy question first. Success breeds success, right? Ask an easy question, get an easy answer, plug it back into your understanding of the data, and then keep going. And then you'll see how we work through this. We end up ultimately asking and answering harder questions as we go. So it seems like a lot of folks in the room are familiar with Elastic, so I'm not going to break out the presentation to click on these links, but I'm just going to say you all probably are able to use search engines better than I am, right? It's very easy to Google Elastic, and then you can read all of their general information about what it is, how it works. High level, in the beginning there was ELK, right? Elasticsearch, Logstash, and Kibana. ELK, which was a really cool name, right? Now, we call that Elastic because it got rebranded. Then they added Beats, which is a new way to pull in data that is outside the scope of the talk for today. It's really, really cool, but it's just not inside the scope of what I'm going to talk about. The next link right here, you can see they already have predefined solutions for all sorts of different security data issues, right? So authentication logs, audit data, NetFlow, DNS, SIM. So you can go and you can look at that and then try to replicate work that they've already built for you. And that's pretty groovy. So this data here is directly off of their website, okay? Elasticsearch is a distributed, RESTful search and analytics engine, right? Okay, we get it. That's the core. Logstash, open source server-side data processing. Pulls in data, transforms it, sends it back to your favorite stash. Kibana is the web front end, right? And that's all it is. Now, just for the record, I love this tool. I'm giving a whole talk about how to use this tool, but these are some pretty salesy definitions, right? And from my perspective, they're not 100% helpful. So just bear with me. This is the order that we use them, right? We use Logstash to ingest data. We stuff that data into Elasticsearch. We use the Kibana web front end to query the data. I'm old. My brain doesn't work like I wish it did. I need things simple. For me, I wish that they had just presented it this way from the very beginning. The problem is that LEC is just not a very cool name, right? So we had to name it ELK because that's like, there's joy because that's an animal. But really, you load the data, you have the data, you use a web front end to access the data. That's how the tool works. And most of you already need it. So, knock on wood, someone was making fun of me that I'm doing a live demo today, so knock on plastic of some sort. We have my laptop right here. I have a server that's in an AWS instance. I get to that with public private key authentication. I then have tunnels set up where I'm tunneling my web traffic through my SSH connection. Okay? Does anybody have any questions about this line right here? Does everybody understand how to do SSH tunnels? We're all cool with that, right? Fairly straightforward. Not really a big deal. Whoops, I clicked on it. Why did I do that, right? But, so I just SSH, give them my login name, and basically saying this port of the local host is going to go this port to the target server. I did that, and that's what's going to allow me to browse, and it's all going to go through my SSH tunnel. And then there are some access controls. How many folks have AWS experience? Only a few. Okay, let me pause just for a second. AWS is not hard. It's a little scary because it's clicky. You have to click on like 15 things before your stuff pops up and is working. And invariably, you're either going to be in the wrong VPC, or your security group is going to get funny, and then you're going to get confused. But here's the glory of it. Then you throw it all away and start over, right? So it's not, you didn't lose anything. It only took a minute to do the click. So with AWS, how it works, you have your virtual server, you have it all set up with whatever you want, you make sure it's on the correct network, then they have a thing called a security group. The security group looks an awful lot like what 15 years ago we would call firewalls, right? Where we just say, I'm going to allow access from this network range to port 22, which is SSH, thank you very much, right? So in my case, from my laptop, VPN into my corporate network, then my security group rule in Amazon says, allow the semantic corporate network to access this host on port 22. Make sense? Okay. Groovy, groovy, groovy. We're zooming through on time. We're going to get done early. I can feel it. Okay. So loading the data. There's just a link, okay, for log to timeline. The situation here is, say I have some Linux data. Like I have a Linux host or some Linux evidence. I want to create a super timeline of every single file on this Linux instance. I do that with log to timeline. And this is how I do it. I just log to timeline.py. The output is going to be output.plazo. And then this input directory is every single Linux folder that I wanted to include in the processing. Okay? Once that's all been processed, I use psort, output directly to Elastic on my local host. So obviously I'm running this command on my analysis server in AWS, right? Sending the data over port 9200 with raw fields. This is whatever the name of the index is. And then the source.plazo is this output.plazo that I started with. So I start with operating system data, I turn it into a super timeline, then I use psort to load the super timeline into Elastic. In just a few minutes, we'll be looking at the Linux data, and that's how we got it in. Right? Now, this is sort of embarrassing, but I just have to admit it. The very best reference I have for how to create a logstash configuration file is in the answer to a Stack Overflow question. Go figure. The actual documentation for this is not the best, but this link gives us a fantastic explanation. And what they're basically telling you is, listen, you have 3 sections. You have input, filter, and output. You configure those sections correctly, then you run logstash, -f means with this file as my conf file, and then give it the path to the conf file. Does that all make sense? All right, so I will show some of that. Actually, here, let's see what we can do. Access to the internet works, that's something. I'm getting brave trying to jump in and out of the presentation. We'll see if we can get back into the presentation. Right? So this is what that comp file looks like. Right? You just say input, file, what the path is, start position, all right? Then it's whatever your arbitrary CSV is. Whatever the columns are, you just put the columns in, and then you say you're going to output to Elasticsearch, localhost on port 9200. In this case, this is their index. You would just change that to whatever your index is, right? That's just super pretty and makes perfect sense. And then they talk here about how to use it and the different problems this person was having and what have you. But again, funnily enough, this Stack Overflow, for the person who had a question and some answers, and then that's the command to run, for me, was the best explanation I had seen of exactly sort of how that works. Okay? All right. Here. Hey, it worked. Bravery. Okay, so we're not going to bore you from watching a bunch of data that you can't read fly by the screen, but when you do that, right, when you've configured your conf file, then you said bin log stash dash f path to my conf file, this is what happens, right? In this case, I'm loading some malware research data, and the fields are IP address, well, that's the IP address. Domain, that's the domain. Timestamp, that's the time that I loaded it. Message, right? In this case, the message is an MP5, a domain, and an IP address, comma separated. Then the path is the local system path to the file that's being processed, the host, and then the ultimate MP5. So these, all of these fields with all of these values, you will see in just a minute, right? So that's what it looks like when you load the data. There are a handful of things you have to do with Elastic to manage the data store. Now again, I'm going to go through this quick because most of you said you already have some experience here. When I was just starting to learn how to use this technology, this confused me for more minutes, hours, than I want to admit, okay? There's two critical things you need in order to have the data and then to be able to query the data, and they're almost exactly the same, which then makes it confusing, right? There's an index. The index is, for better word, it's like the database, right? It has a mapping which defines types, and then you put data in the database. So there's an index that has to be created. And you can do that in the dev tools. You could also do that with curl or in the bar, I suppose, with like a post or something. So you have to create the index. And that is done on the Elasticsearch side, right? And we remember that Elasticsearch is the data store component. So we create an index on the data store. Then we have to create an index pattern, which, funnily enough, is usually the name of your index with a wildcard at the end, right? So it's very similar. And the index pattern gets created in the web front end. And you use that index pattern to retrieve data from the Elasticsearch index. And you use that for the different visualizations and that sort of thing. So all I'm trying to say here is that if it's Elasticsearch, it's an index, and you deal with index management. And then if it's in Kibana, it's an index pattern, and you configure the index pattern. If it seems a little pedantic, I agree. But please just trust me, if you get it confused, you then feel like a knucklehead when you realize what you have done. So now let's talk about using the front end a little bit, right? So, someone who has some experience, what is this first one going to do?
List all out the indexes.
It's going to list, it should list out the indexes. Do we agree? I got to click on the buttons. All right. And then similar here, this one would look at the cluster health, okay? So let's just for a moment, let's see if we can do this and see what happens. All right? Minimize these things. Getting really brave. Doing stuff on the command line. Certainly frightening. And it worked. It worked so fast you probably almost don't believe it worked. But there you are, right? Everybody knows what curl is. Anyone not know what curl is? Be brave. Yeah, okay, great. Thank you so much. So curl is a text-based application that you can use as a browser. It's like a super, super minimal text-based browser, effectively. Okay? So I'm just saying curl, do a get, to localhost on this port, this URI, right, this path, and then here are all of the indexes. Pretty groovy, all right? Now, I made this part orange on purpose, just to show that there's more than one way to do things, all right? Maybe you need to use it in curl for whatever reason, okay? And if so, that's totally fine. But you can also do it in your browser, right? Just get rid of the curl part, right? You saw what I did there, right? I just localhost 9200, the path, _ cat / indices, blah, blah, blah. And then you can look at all of our indices that way. So I run into this stuff all the time. There's a certain type of person, mad, that is going to think that you have to do it with the command line, you've got to do it the hardest way possible, and you have to wear a black t-shirt everywhere you go. I'm totally buying one of these black t-shirts, by the way, because they're awesome. So I have no issues with black t-shirts. But you know what I'm talking about, right? Like eggheads who do it hard on purpose. Listen, this tool is for everybody, and if you want to do it with the command line, there's a lot of good reasons to do so, but there's also no problem with using the browser and just checking some stuff out that way. My whole point is just to say that you could do it multiple different ways, okay? All right? And this is the very same kind of thing. Cluster health, right? So maybe I'm just, as part of a script, that would be a reason to do this on the command line with curl. Maybe it would be part of a script or something that every day I would check my cluster health, right? But now, if just for whatever I wanted to check in, I gave my cluster a really awesome name. By the way, there's only one server, but it's still a cluster. Don't ask. That's why the status is yellow, because I don't really have a backup, right? So you see number of nodes, right? Number of data nodes, active shards, and you just have all this nice information about the health of your instance. Big deal, but that's how you use it. You can do it with the command line or with your browser. So I took a moment to talk about indexes and index patterns. You obviously need to create indexes if you're going to do stuff with Kibana. There are also multiple ways to do that. However, I'll show you what I believe to be the easiest way. Are you kidding? See, live demo. Kibana listens on 5601 by default. So when I just say localhost on my browser, it tries to go like port 80, right? I hate making mistakes, but I make mistakes all the time. Go figure. All right. So dev tools. Fantastic. Right? So right in here is where you would use your dev tools to create an index. Very cool. You can also, recently, there are some additions for SQL searching. So you can use SQL type syntax to do some searching. And again, let me take a real quick. I had a whole bunch of stuff set up that I seem to have lost. That'll happen. I'm going to move on in the essence of time, but I promise it works, and I'll come back to it at the end to show it to you. That's my mistake on my presentation. So then we can do some direct browsing. We can use, primarily we use Discover. We can use some visualizations in the dashboard. So let's get into that just a little bit, right? So you remember I talked about index patterns. You see this right here, Shakes star. That lets you know that we're querying the Shakespeare data set, right? So maybe I want to know about the speaker and the play name and the text entry, right? Just for argument's sake. So I'm looking here. Maybe I am interested, for whatever reason, in text entry this, show me all the lines that has the word love in the line, right? Because it's Shakespeare. There's lots of love in Shakespeare. There's 1,857 hits of love in Shakespeare, okay? That's just using discovery. I'm going to continue on with this example in just a minute. Visualize is where you can create visualizations that you can use later. So, Shakespeare line count by play. Right? So this is how many lines by play. Now, this is really what separates the eggheads from the cool people. So, if you think what I show you next is really cool, then you're an egghead like me, and we should accept it. If you don't think it's super cool, probably means it's because you're super cool. But wait for it, okay? So I can do my Lucian query, right? I can do my filter, right? And I can immediately apply my filter to my visualization. So the real smart prep work is to create visualizations that then empower analysts to ask cool questions and get cool answers wicked fast and already graphed for you, right? So for me, that is really, really cool. Now, if I wanted to, right, and there are going to be people who solve the problem this way too. Line count by play, love, okay? So you save the visualization with the search already hit, right? Now let's just say that I'm starting a punk band, and that band is called Love, Hate, Robot. And I'm interested in drawing a connection between Love, Hate, Robot and Shakespeare. It's part of my marketing plan, just roll with me, okay? So if I built the solution this way, I've got to create 3 visualizations, right? And there's some value to that because maybe I want to see all 3 of them at once. And if that's what I want, fine. Create 3 visualizations and do that. Most of my job as an analyst isn't creating visualizations, though. I'm just trying to find out the answer to the question. So for me, personally, right, I would prefer the more granular visualization where I could then say there were 1,857 lines in the entire corpus of Shakespeare that had the word love in them. Okay? Well, that's great. Now, instead of love, we'll do hate. There are much less, by the way, right? Like 18, 16, you know? Much less hate in Shakespeare. That's good. Now, because we're all trying to use this tool to be analysts, how many plays have the word robot in them?
0.
You're a wizard. You're a wizard, Harry. Okay, absolutely. There are zero Shakespeare plays that have the word robot in them. We are not surprised, right? Let me just pause to say, this is a really important part of data analysis. You expect for no results to be returned. Make sure no results are returned. It just helps avoid embarrassing problems later when I search for robot and it gives me some answer that's clearly not correct, which means I have a problem, right? Okay, very, very cool. You are all super patient and super awesome. Now, I said I was going to give you my demo. I love Dilbert. Thank you to Dilbert, by the by. And you would definitely be saying, I got to get me some of that, right? We've already started going through Shakespeare. I'm just not popping the whole slide deck back up again because I'm going to go right back into the looking, right? It's really a pre-example. It's not security data. Some of you are ready to get out. But I just wanted to show you a couple things. Number one, just look at the general concept, right? Like how the tool works. Number two, it's pretty fast, right? It's really fast on text data, which is awesome. So that means you can have arbitrary data. It doesn't have to be a relational database. I'm old. It took a long time for me to get over the fact that this is not a relational database. I just throw it all in and then type Google-like queries and then I get answers. Groovy, right? Okay, so we've talked about that. So who's ready for a slightly better demo? So we're going to look at a field, parser, and then we're going to filter out file step. And we're going to talk about that for a minute. Hopefully one of you is going to ask a good question, or maybe at least just talk it all. All right? And then ultimately, we're going to search for password. Keeping it pretty basic for right now, all right? Okay, so now, just so that you believe that I did it on purpose, I'm about to make a mistake. What's my mistake? I mean, really, there's more than one.
Searching the data set.
I'm searching the wrong data set. I absolutely agree. How do you know that? Because it says right here, shakes, right? I'm using the index pattern, shake star, which is referencing the index, Shakespeare. Oops. Of course that didn't work. Now I set that up as this like fantastic Socratic example. In my day-to-day life, I do it all the time. You will too. Don't worry. Just tell whoever's watching, that's what makes you good, and move on. All right? So, Linux evidence star, right? That's probably the one we want. Do we agree? So, basically, that's just like selecting a whole new database. Now, because the tool is, more or less free in the instance I'm using it anyway, you do get a couple of weird holdovers, and so just please, if you're new to the tool or whatever and you're playing with it, don't get discouraged or frustrated. It held on to this query, right? It thinks I might want to use it or something, so let's just delete it to get rid of it, okay? Oh no, I'm doing a presentation in front of roughly 30 people. All my data's gone. I don't know what to do. What's actually happening to me? Anybody? Is it likely that the forensic analysis that I have normalized and then am presenting to you happened 15 minutes ago? No. This is a huge gotcha in the tool. It always defaults to the last 15 minutes because the use case they're thinking of is near real-time monitoring, right? But I'm looking at historical data. So I've changed to Linux evidence star. I think I'm looking at my right data set. I think I'm doing all the right things. And then I freak out because I forgot that way over here in this upper right-hand corner, I want to do something like that. Like show me all the data over the last 5 years. Ha! 1 million hits. That's better. That sounds more like what I did, right? So remember we talked about a couple slides ago. I used log to timeline on a whole bunch of Linux file system folders. Created a super timeline out of that, which is a .plaso file. I then used psort to dump that .plaso file into Elastic. It was 1 million records, a little more than 1 million records. Took about 6 hours to do, which is kind of slow, and I was disappointed that it took so long. But that's how long it took. I ran it overnight and whatever. By the way, this is a real live case. Like I had a real live customer. They paid us real live money because they had a problem on this particular. Interestingly enough, it wasn't a bare metal system. It was a virtualized system inside of a Docker container that was being managed with LXC. Okay, so I took this host data, did all this stuff to it, and dumped it in here. Now, remember I warned you that there are still these wonky parts of the UI. Is there a speaker and a play name and a text entry for Linux evidence.star? Absolutely not. So wouldn't it have been nice if they had refreshed for me? I'm sure there's a reason it doesn't, okay? But all I know is that it's scary to me and slightly irritating. No big deal. So let's add parser, because I gave you a clue that we were going to be interested in parser, right? And then message. Sorry, that's loud. Message is the catch-all, right? It's the entire record. A lot of the other fields are basically parsed out parts of message. So when I'm doing my analysis, I just start with message. And then maybe I use other fields when I need to. Now here's the interesting thing, like check out how cool this is. click on the plus magnifying glass to filter for the value, the minus magnifying glass to filter out the value. So check this out. I have a lot less data now, right? This is an artifact of the way that I collected the evidence. There were roughly 1 million files in the folder structure I was analyzing. I got a row in my data set here for the date timestamp of every dadgum file in the file set, right? I might ultimately need that. But for my first pass of analysis, is it likely that I care when a particular file was last, right? Probably not. So I can get rid of that. Now, I know that it's a Linux system, and I'm especially concerned about any sort of user activity that was incorrect, was the particular case I was looking at. So, gosh darn autocorrect, right? You saw that, right? PASSWD, right? I promised that this was not a doctored data set. This was a real case. But it was just a great example to use. Exactly one record was returned, okay? And a little over a year ago, 2017, not 2018, a little over a year ago, the password for the user Ubuntu was changed by the user root, and that's the process ID number that did it. And then if you click here to expand, this is all the detailed data we have about that record, okay? Now, I thought we had tons of time, and then now I've apparently slowed down, so I'm going to zoom on. If anyone has questions, just feel free, like, dive in and ask their question. Yes, sir?
So I'm not an IT person, so I don't want to waste people's time in the room who know stuff. I worked for a bank for a long time. I used Microsoft Access. I use Excel to create like really broken databases. So just help me understand, like in lay terms, like what does Elastic do that's so brilliant? I mean, if you're showing awesome results, but how does it do that?
Very great question. Okay. The short answer is that the under the hood part is a bunch of sort of NoSQL type technologies that are happening in the Elasticsearch piece of that Logstash Elasticsearch and Kibana component, right? I'm not really an expert, so I can't tell you too much more beyond like that it's all happening. What makes it so great, right, is that they abstract that for us, right? I don't have to know how the internals of the database works to query the database, and that's kind of what's happening here, right? I can just, yeah, I can just use my search bar, but that's a great question, and if it's something that's interesting, I'm happy to look it up for you, with you, and we'll sort it out. But that's a super good question. All right, so I want to move on to looking at some Apache 2 web logs real quick, because I did, you know, I also haven't forgotten, and I want to go back to that other thing. Nice, but here we go. Let's go here, container Apache 2. Let's remove that filter. Let's get that out of here. Let's get that out of here. All right. Now this is my dashboard. Now, a dashboard is nothing more than a collection of visualizations, right? So I showed you a handful of visualizations. Now I thought it was really groovy to have a bunch of them together, so I put them all on a dashboard. Woohoo! Down here, you would see a list of IP addresses. I told you before this is a real live case that I was working on. So I removed all the IP addresses from the visualization to protect the innocent as well as the guilty. Okay? So whoever, you know, thinks they're not super technical, which one of these rows here is the one that you think I'm going to look at first?
Which one? The columns? The bar?
Yeah, which one of the bars? You're right, it's column. I'm sorry.
Big one.
The big one? Yeah, absolutely, right? The very first one I'm going to look at is, gosh, this particular IP address generated, almost 12,000 log lines in the last 30 days. Now, I don't want to hover over it because I don't want you to see all about the IP address, but there he is. Okay, woohoo. All right, whatever. Okay, so great. As it turns out, that was definitely the person. The background was this individual found a web vulnerability and then tried to prove their ability to exploit it, and then presented themselves as an information security researcher and suggested that the company pay them a lot of money. The company said, that's not how responsible vulnerability disclosure works. You're breaking the law. Got me involved, got my company involved, and then we had to do a whole bunch of things. So one of the things we did was say, yep, this is definitely the person, and this is where that IP address resolves to, and this is where they live, and all of that stuff. Which, interestingly enough, the individual gave their real live phone number in their, what technically was an extortion attempt. Although they worded it just right that they felt like it wasn't extortion, right? They gave out their own phone number. This is like how not to be a criminal. Yes, sir?
Does this organization have a bounty program or no?
They do not have a public bounty program. So here's where it was really interesting, and this is just hopefully relevant, right? Like to folks that are like, listen, I like breaking stuff. I totally like breaking stuff. But if it's not your stuff, be careful, all right? Just be careful. So I've been involved in a number of cases like this, right? This individual thought they were doing something good, were hoping to get a financial reward for doing something good, but the way they presented it was not the best, okay? So first of all, after they found it, the part where they sent 12,000 more web requests over the span of 54 minutes, probably a bad idea. Probably a bad idea, okay? Had they said something like, hey, listen, I'm a little bit of an aficionado, I know a little bit about this stuff, I kind of stumbled onto this, I want to respect your systems, but this is what I think I saw. You guys don't happen to have a bounty program, do you? Like, there's a way to share the information that you find that doesn't scare the bejesus out of people. This person did not do that. So then I got pulled in, and then they're like, can you prove he did nothing else? Right? The first thing I said was, how do you know it's a he? But then it was because he provided his real phone number, so it wasn't very hard. Okay,
Well, it
so
goes beyond just knocking on the door, you went in.
well, an argument can be made when you expose an API to the internet, right? And that's what had happened. These were APIs that should have been internal, but they were exposed to the internet. So I don't mean to get to the last one, and then I'm going to go on.
Well, which country was the server and which country was the researcher in? Supposed researcher.
They were both in the United States.
Okay.
So I'm not a lawyer, nor do I play one on television. All that I am saying as a technologist, when you find a vulnerability and you have not already been paid and contracted and are protected under a limitation of liability to perform vulnerability scanning, right? Because if you're a professional pen tester, which I have done that job for years and years and years, if you're a professional pen tester, you don't touch the system until you get that scope of work. Because part of what that scope of work does is it provides you authorization, it provides limitations of liability, right? And usually, the limitation of the liability is the total dollar value of the gig. So that me as a pen tester, the worst thing that can happen to me is I get paid $0 for the gig, right? As opposed to, you can come and repo my house, right? So just remember the next time you're a Robin Hood on the internet who's found this thing, you're walking without a net, right? You don't have a limitation of liability, so please tread light. Is my random side note that has nothing to do with Elastic. So moving on. All right, check this out. I think this is super cool too. If you think this is cool, you're an egghead like me, we should drink beer. If you don't think this is cool, it's because you're cooler than me. We should still drink beer. Okay, so. There were this many 200s. What is HTTP response 200? Okay, all right. Well, that's cool. Check this out. If I double click on it, it immediately turned it into a filter. It doesn't have to be hard. They make it easy for us, right? I think that's really super cool, all right? By the way, our person had the most 200s also, which one would have expected, okay? That's pretty neat. Well, let's edit this filter for a second though. Response.keyword is not 200. Let's run that instead. Our person is still the most, because they just dominated everything, right? They're the only person banging on this thing at this time, right? But this is groovy information because this is showing me the 500s, the 404s, the 302s, right? This is showing me all of the errors that got generated, right? If I wanted to leave their IP address up on the screen a little longer, now I could see all of them just by our particular individual, right? The pointy-eared bosses lost their mind, right? Because I clicked on a button and they saw everything the perpetrator had done. I was in. I was golden. Like it did. At that point in the gig, it doesn't matter what else I do. Like I have won, right? The customer is going to think I am a wizard. Like Gandalf is nothing compared to me, right? Because I have pretty pictures that are dynamic, right? And I'm not trying to be insulting of executives, right? But executives have a very short attention span for a reason. They've got a lot of different things they have to do. If it takes you 55 minutes to explain something to them, you lost them, right? So dynamic graphics, boom, boom, boom. And they felt like they understood. And so that's what made them happy. All right? Just zooming on. This is also an interesting piece of data. If you Google Node superagent, you'll see that this person was definitely amateur in what they were doing and how they were doing it. Like, big deal, whatever. These are a whole bunch of different access log files. This is just a heat map showing you that the server in question was normally seeing this much traffic, and then all of a sudden, right? Normally we see 100 records, now we see 1,000 records, right? A change by an entire order of magnitude. Obviously something's going on. That's all that is, okay? Any questions about that before we move on to the next example?
Is this person in jail?
No, not at all. So, again, just side note, my analysis, just for your general storytelling, okay? My take was this person was very amateur. There was evidence of the amateur nature based on the number of failed attempts, based on the thousands of repeat attempts that added no extra value. The person just sort of kept clicking on it because they thought it was cool, right? So obvious amateur. This was if there were crimes, which I did not concede, if there were crimes, they were clearly committed out of ignorance, not out of maliciousness. There was no actual harm done to the company. And my suggestion was use this as a, okay, look, I need to encrypt my whatever. Use this as a motivator to create a bounty program. Perhaps, we could caution this individual a little bit about like, hey, we don't really appreciate this. I mean, thank you, but don't do this anymore, was my take. Not trying to push my politics on people, but my general feeling is that we have too many people in jail that we need working, right? So how about we give this person a little bit of education, a little bit of encouragement, and remind them about limitations of liability, and don't do this, okay? Something else happened to me with a kid, like a real kid on the West Coast, same deal, and like they had the FBI involved and they wanted to send this guy to jail. And that's a really awkward conversation as a technologist. When you've got a person who carries a gun as a part of their job, talking to an adjunct college professor guy who lives in New York. He's made a bunch of assumptions about me, and I made a bunch of assumptions about him. And trying to say, listen, he was trying to help. You know what I mean? Like, let's keep kids out of jail. Let's put kids to work. It's what we're going for. Okay. Distracted, but that's important. One more dashboard, okay? So, similar. Now, just sort of watch how this happens. If I go back to dashboard, passive DNS. This data is all coming from Georgia Tech. They have a research program. My status with Albany allowed me to use the impact data request. They share this like malware data with me. I've collected all this data and stuffed it in here, and I do groovy stuff with it, right? So again, looking at this dashboard, these are the top 25 domains that they have seen over the last 30 days, right? Google.com. Not really surprised, right? And then what does that mean, and what do we do with it? This one is really odd to me. I haven't actually had time to dig into this. This is, you will sympathize with this. This is all in preparation for the torture that I'm going to give to the students who take my class in the fall. One of the questions I'm going to make them answer is, what exactly is kiss.marketchickens.men? And why is so much malware going through it? By the way, I didn't even know .men was a TLD. I feel so old. Okay, all right. So this is just me showing you a pie chart because everybody needs pie charts in reality, right? Like how big of a deal is this? But listen, you can just see, on the 14th, 15th, 16th, 17th, 19th, 20th, and 21st. If you were paying really close attention there, you'll notice I have a skip in my data. I don't know why. They didn't give me a data file for these 2 days. And I wanted to pause and talk about this just for a minute. In the real world, remember I said way back at the beginning, we're not statisticians, we're trying to answer questions in the real world. This crap happens all the time. I had a reliable data source. For whatever reason, now I have this 2-day void where I don't have malware data. Is that going to break my research? Probably not, because I designed it in a certain way that it doesn't really matter. But if I was, doing a job, would that really confuse a pointy-haired boss? Absolutely. So when that kind of stuff happens, for whatever it's worth, shine light on it, don't hide from it, and then drive forward, right? So I have a hole in my data set, big deal. It's a real-world data set, happens all the time. It's how people know that you're doing it for real, right? If the data's too pretty, you probably faked that anti-vax research. Okay, moving on. Right? Okay, all right. So this is actually a really interesting table. I want to pause for a second just to show. This IP address, this 23.253.126.58, it's super noisy, lots of malware is getting bounced off this IP all the time. What I was then interested in, though, is I was like, yeah, but show me like the top 3 domains that are being hosted on that IP. And then all the rest just concatenate together as other, right? So that's why you get 4 rows for each IP address. This is what I mean when I say you have to understand your data. If you don't understand your data and you don't understand the question you're asking, this kind of just looks like a messed up table, right? It looks like a little weird. Why are there 4 rows with the same IP address? The answer is, why are there 4 rows? alltruckqueenoclothes.com has happened 4,500 times. wxanalytics.ru has happened 708 times. c1homelevel.in has happened 609 times. And then 64,000 others, right? And I was interested in that because the specific question for the students in the fall is, can we create, or even better yet, can we devise a system that automatically creates classifications for these IPs? The kind that are only hosting onesie-twosies, the kind that are hosting domains that are more, longer in life, that happen, thousands and thousands of times, that sort of thing. So that's the kind of thing you can do with the table. Top MD5s. Similarly, I could say the top MD5s from a particular domain, top MD5s from a particular area of time, whatever. I could then grab these MD5s, search them by virus total, do a whole bunch of other things. Not really that big a deal. This is another example of heat map stuff. And then this is another example of looking up domains. All right, so it is 3:55. In my defense, we really didn't get started until straight away. So apologies to the next presenter, I'm sure. Feel free to come on up. I'll be done in just a second. But okay. So this is me. I absolutely cheated through at least 1 or 2 parts. So if you have extra questions or if you're interested in this at all, fantastic. And please feel free to send me a mail at work or to send me a mail at school. And I'd be happy to talk about, what we're doing with the technology, how we use it for incident response, how we use it for other things, and basically anything at all, really. So Very quickly though, are there any questions? Does anybody have anything before we call it a wrap?